From the City of Angels near the Pacific Ocean, good morning, good evening, wherever you may be across the nation, around the world. I'm George Norrie. This is Coast to Coast AM. Later tonight, investigative reporter Cheryl Jones on flying cars, followed by open lines, and then we'll end the program with a special tribute to the late Kevin Mitnick, Coast to Coast guest. Here's what's happening. An intensifying heat wave descended on the eastern United States Thursday, prompting warnings about the dangers presented by the sweltering heat and humidity in the final days of a record-smashing July around the world. Some 180 million Americans, about half the population of the U.S., are under heat watches and warnings, with temperatures and heat index values well above 100 degrees in the forecast until at least Saturday. Randy Meisner, the retired American singer and co-founding member of the Eagles, has died in Los Angeles due to complications from chronic obstructive pulmonary disease, COPD. According to a statement shared by the band on their website, he was 77 years old. Meisner, along with Glenn Frey, Don Henley, and Bernie Leadon, formed the Eagles in 1971. He co-wrote the band's hit song, Take It to the Limit, dead at the age of 77. Strength training exercises such as wall squats or holding the plank position are among the best ways to lower blood pressure, according to a study. Current guidance focusing mainly on walking, running, and cycling should be updated, according to the researchers. Analysis published in the British Journal of Sports Medicine of trials involving 16,000 people found all exercise, however, lowered blood pressure. Basketball great LeBron James' son, 18-year-old Bronny James, was discharged from a Southern California hospital days after he suffered cardiac arrest during a basketball workout, according to doctors. It's an incredible story. Christian Wilde, author of MyHeartBook.com and his website, MyHeartBook.com, as well, is with us. Christian, this is unusual for a 18-year-old to have a heart attack, isn't it?
No, it isn't really, George, because there's 20,000 cases a year where this happens. It happens more to boy athletes than girls, but it does still affect them also. The news carried the story of the son of NBA star LeBron James, yes, that he had been stricken by cardiac arrest. Now, that's a condition, George, that claims about 20,000 lives of young people involved in sports each year in the United States.
20,000?
20,000, and here's what we can learn from this. It can happen without warning. About two-thirds more boys than girls are found to have this ailment, and more among basketball and football players than in other sports. So imagine the gratitude this father, a man of deep religious faith, and Mother Savannah must have felt to hear the good news that their boy, Ronnie, was going to live. The family was quick to thank all of you out there who had been thinking of them and praying for a miracle, which they apparently, George, they got it in learning that their son would survive the heart event.
Well, let me ask you this, Christian. He was number 20 on the list of top picks of potential collegiate and professional basketball players.
Yes, he was.
Is he going to be able to come back?
From here, we don't know.
So, can you literally come back and play basketball again after something like this?
It depends on his individual damage. Some people have a very, very light damage. Others have a more critical one.
Which they haven't told us yet.
Now, there is some life-saving information from all those who have young children involved in sports that may apply as an ounce of prevention with a little cardiac evaluation of their child before they get involved in young people's sports. It might save them all the agony that this family just went through and the other families of 20,000 people a year. Exploring a little family history for past arrhythmia or heart attacks may be a good place to start. You may be wondering, what's the difference between cardiac arrest and heart attack? In cardiac arrest, the heart stops beating and blood flow and oxygen are cut off to the brain and other organs. Now, compared to heart attack, when blood to the heart muscle itself is actually cut off or limited. But let's share some good news today that LeBron's son is out of the hospital and doing well.
All right, to me, a cardiac arrest and heart attack are the same thing. It still affects you. Thanks, Christian. Christian's website, myheartbook.com. Former Navy pilot and Americans for Safe Aerospace Executive Director Ryan Graves reacted to the historic hearings yesterday on UFOs, calling it an inflection point, referring to UAPs, unidentified aerial phenomena. Clips of Graves and two other whistleblowers, David Fravor, former commanding officer in the Navy, and David Grush, the U.S. Air Force officer and former intelligence official, have gone viral after they gave sworn testimony in front of Congress as to personal experiences of what many Americans would describe as UFOs. Kevin Randall, of course, would definitely call them UFOs, wouldn't you, Kev?
What did you say, George? I missed the first part of that.
You'd call them UFOs.
Oh, yes, UFOs. When you switched me into the sound, there was a sound and I didn't hear the UFO part.
What'd you think of the hearing?
Well, I did sit through the whole UAP congressional hearings yesterday, and no, unlike so many of my colleagues, I was unimpressed.
Really? Why?
I heard and saw nothing new here. I knew days ago who the witnesses would be and hoped that some of David Crush's sources would be revealed. With hints about sources, we could have begun the process of verification, but without them, we just have some interesting tales that might be more fiction than fact.
All right, my friend, what do you have for us this week?
Well, here are some of the things that I noticed during the hearings. There was a great deal of talk about transparency, but little talk about sources, sightings, or results. There was a great deal of talk about national security, and most of us could figure out what that meant. Revelation that the U.S. was in possession of alien spacecraft, or rather proof of that, could certainly affect national security. Our competitors in the world would fear that we might learn about the operation of the alien spacecraft and what sort of advantage that would give us. Representative Dave Grothman, who chaired the panel, asked if witnesses thought the UAP posed a threat to national security, and Commander David Fravor, the Navy pilot involved with the Tic Tac sighting, said yes. Another of the representatives asked if he, Grush, had met with people with a direct knowledge of non-human craft. Grush said that he had personally interviewed those individuals but provided no names or sources. On the other hand, Don Schmidt, Tom Carey, and I have interviewed first-hand witnesses. We talked with former counterintelligence agents who had direct knowledge, and we've also talked with civilians who had specific and direct knowledge, such as Bill Brazel. Without the witness names and other sources, there's little that we can do to validate the claims made, and as I say, I hoped for a little more detail. Ryan Graves, one of the witnesses, did mention a sighting at Edwards Air Force Base. The witnesses to the sighting were civilian contractors talking about a huge object. He didn't provide much in the way of detail, but it did remind me of a somewhat similar sighting that took place for tonight's retro case. Charles Moore, yes, he of mogul fame, made a UFO report to Project Blue Book. The sighting near Array, New Mexico on April 24th, 1949 is multiple witness and used instrumentality to observe the object. Moore, along with a crew from General Mills, were launching balloons. They released a 350-gram balloon about 10:20 a.m. Mountain Standard Time and were following it with a standard telescope. Moore made a reading at 10:30 a.m. Moore later said that he thought that he had the balloon in sight when he picked up a whitish spherical object that was drifting east rapidly. When the distance between the ground station and the supposed balloon became apparent, he took over the telescope and found the true balloon was still there. The object was ellipsoid, white in color except for the light yellow on one of the sides, as though it was in a shadow. He saw no good detail. They lost sight of the object in the distance after watching it for about 60 seconds. They made measurements using the equipment and stopwatch, but they took no photographs. They reported the sighting, and it became part of the Project Blue Book files. Originally, it was classified secret, but it was downgraded later in accordance with regulations. and it is one of the unidentified sightings in the file. And that's what we have for tonight, George.
All right, Kev, we'll talk to you next week, my friend. Kevin Randall, who monitors UFO reports for us. Up next, Michael Rampino back with us. Will an asteroid take us out one day? That's just one of the things we'll talk about with him next on Coast to Coast AM. And welcome back to Coast. George Norrie with you. Michael Rampino back with us. Michael is a professor of biology and environmental studies at New York University. He's been a consultant for NASA, is the editor of Climate, History, Curiosity, and Predictability, and co-authors of Origins of Life in the Universe. And here he is back on Coast to Coast. Hi, Michael. How have you been?
I've been fine, George.
Good to talk to you. What do you think of this heat wave that's hitting the globe? My God.
Well, George, I worked in climate research back in the 1980s, and we were doing climate modeling, simulations of what the climate would be, 20, 30, 40 years in the future. And the calculations that we did at the time and we published for what things would be like in the 2020s were exactly right on to what's happening now. So it's not a surprise to most climate scientists who follow the literature and know the science that we're seeing these kinds of temperatures. It's just what we predicted would happen with the increasing amounts of greenhouse gases that we've been putting in the atmosphere basically by burning fossil fuels. So it's no surprise.
Is anything, Michael, also happening to the sun? Is it getting warmer?
No, the sun, there's no indication that the amount of solar energy coming from the sun is changing. The change is in the amount of greenhouse gases in the atmosphere. It's very simple physics. The more greenhouse gases you put into the atmosphere, the warmer the climate gets. It's very, very, very straightforward, simple physics. And we've been pouring CO2 and other greenhouse gases into the atmosphere now for decades. And as I said, 40 years ago, 35 years ago, we did the science, we did the calculations of what the situation would be if we kept on pouring greenhouse gases into the atmosphere. And the results were, if you read those reports, it's almost like reading the newspapers today. These heat waves and fires and ocean temperatures, 100-degree ocean temperatures off of Florida, all those things were predicted by the science back, as I say, in the 1980s. And if people had taken those predictions more seriously, maybe we'd be 40 years down the road of doing something about the situation. And people say, well, what do we do now? And my feeling is it's too late. We're already seeing these changes, and as we keep putting greenhouse gases into the atmosphere, things are only going to get warmer. They're not going to get better.
And Michael, could this also be an Earth cycle?
No, it's almost definitely, I'd say definitely the result of the human-made CO2 and other greenhouse gases that are coming from energy use. Anytime you burn carbon in coal, in natural gas, in petroleum, you get CO2. There's no way not to have that. And as you use more fossil fuels, the CO2 builds up, and it acts like a blanket that holds in the energy, the climate energy, and it just gets warmer and warmer and warmer. The more CO2 you put into the atmosphere, the warmer it gets.
Does this mean we're going to have a very mild winter?
Could be, but one of the things that when you get this kind of climate change is you get more, I would say, unpredictable kinds of climates. So you might get a winter where you have an abnormally amount of snowfall because there's more moisture in the atmosphere because of the greenhouse effect, and so it's hard to predict. But I certainly predict that the summers, will continue to be as hot or hotter as they have been this summer and in the last couple of years.
This seemed to just creep up on us, didn't it?
Well, none of you were paying attention.
Not of you, or predicting, as you guys.
Yeah, because the climate has been getting warmer and warmer every year. Every year has been warmer than the year before.
Why the big jump, though, on this year?
It's hard to say. These things don't always go smoothly. and so there could be unpredictable jumps and tipping points in various aspects of the climate system. So there's no guarantee that the climate change is going to be gradual and year to year is going to be the same. You can get very unpredictable or sudden jumps in the climate warming.
Michael, 6 years ago, you wrote a book called Cataclysms, A New Geology for the 21st Century. How many asteroids have we tracked that we keep track of? Do you know what that number might be?
Well, we keep track of everything above about a quarter of a mile in diameter. And there are lots of them. And we keep track of most. We found most of them. And none of those that we found, when we plot their orbits into the future, has a collision with us, at least in the next few hundred years. But we haven't found all of them yet of that size. And, even something as small as a few hundred feet across, and we don't know where all of those are, is capable of taking out a city.
Well, that's right.
We know where a lot of the asteroids are, and we've plotted their orbits, and we don't see anything hitting us of that size. But the smaller ones, which can still do a lot of damage, can come out of nowhere. And a lot of times we see these things after they pass us by. They go, oh yeah, we almost had a collision with that one. And we see it after it's gone by us. So there's still a lot of unknowns in tracking these things.
Is it not a matter of just if, but a matter of when, isn't it? Because eventually one of these probably will hit us according to the odds.
Yes, absolutely. It's a question of when. Yes, and by tracking these things, we can see, well, hopefully when. If we track their orbits into the future, and we know where the Earth is going to be. And then we find one, 100 years down the line is on collision with us. Then we know when, and then we can start to think about what we might be able to do about that.
Is blowing it up, Michael, worse than just letting the thing hit?
Well, blowing it up is not a good idea if you just have a lot of smaller things hitting all over the place.
It's like a shotgun.
Yes, that's right. So that doesn't really help. What you want to do is somehow divert it, right? And there have been some experiments now that have been done to see how well we could do that. Hit it with something and see if you could just knock it a little bit off course, and so that by the time it gets to the point where it's going to collide with us, it's off by a certain amount, and therefore it misses us.
On the ones we know about, if they're headed toward the planet, can they chart where it's going to hit and then give these people notice to get the heck out of the city?
I doubt if we'd have that kind of predictability and accuracy for something, small, relatively small, but big enough to wipe out a city. You only need something a few hundred feet across, and we don't know. They're very hard to see, and we don't know where all of them are. And so we find them, as I say, usually we find them after they pass by us and we've had a close encounter. So I wouldn't guarantee that we'd be able to do anything about moving people out of the way or something like that.
Michael, would you be surprised if in a month we call you back to talk about an asteroid that hit the planet? I mean, is it that possible?
Yeah, certainly possible, yes. Yes, not a big one, not a dinosaur killer asteroid, not a mass extinction asteroid, in fact, but a small one, as I say, capable of taking out a city.
Where did these asteroids come from? Were they planets that didn't form, or a planet that blew up? Where did it come from?
Well, the asteroid belt is between Mars and Jupiter, and that's probably a lot of stuff that could have formed a planet, but didn't, because the gravitational pull of Jupiter, it's a very big planet, would have pulled that planet apart. So that's where asteroids come from, that asteroid belt, which, as I say, might have become a planet, but it was just too close to Jupiter to actually stay together. The comets come from way out in the outer parts of the solar system. They're mostly ice, and they come in occasionally when there's some perturbation out there, and it kicks one of the comets into an orbit that passes by the Earth.
Hold on, Michael. We're going to take a break. We'll come back and chat more about your incredible work. Michael Rampino with us. We'll be right back. And welcome back to Coast. George Norrie with you, Michael Rampino with us. Michael, what got you involved in all of this? This is great work.
Well, what got me involved in the geology and the study of the Earth in general was when I was 7 years old. They took me to the Museum of Natural History in Manhattan, and I saw, the dinosaurs, and I saw the meteorites, and I saw the gems and minerals, and I said, hey, this is for me. I want to know more about this stuff, and I stuck with it over the years, and it's worked out pretty well.
Did the asteroid that hit the Earth 60-some million years ago that wiped out the dinosaurs allow us as human beings to evolve?
Yes, well, it was important because the dinosaurs were dominant on the Earth 66 million years ago, and the mammals, the small mammals that were our ancestors, were living along with the dinosaurs, but they were just small, tiny, rat-like, mouse-like animals. And it wasn't until the dinosaurs were taken out of the picture that those little mammals got a chance to evolve into all the present-day mammals we have today in the world, including primates, including us. So we can thank that asteroid 66 million years ago for for humanity. We wouldn't be here today if that asteroid had missed the Earth.
Roughly how many asteroids are considered near misses that buzz by us every year?
Well, I think every year there's around 50.
Wow.
Yeah.
That are close enough to hit us if something goes awry?
Could be, yes. Some of them most of them pass by closer than the moon, right? So they're pretty close to the Earth, but there's still a rather wide range there. So nothing that we know of now that we've predicted the orbits for is on a collision course with the Earth. But sometimes things pop out of nowhere and on strange orbits, and you never know when an impact might take place.
Michael, what about volcanoes? How dangerous are they to us?
Well, the volcanoes most of them are dangerous for local and regional areas, right? If you're near the volcano and it's an explosive volcano that erupts, there's going to be damage and there's going to be a loss of life in the area of the volcano. But if the volcano is big enough, an explosive volcano is large enough, what we call super volcanoes, then they can put so much material up into the atmosphere. That's the problem. When they explode, a lot of fine dust and droplets of sulfuric acid go up into the upper atmosphere, and they cut out some of the sunlight that will be coming and warming the planet. And so after historical eruptions, we've seen coolings lasting for 2 or 3 years after those eruptions. And when we do the calculations of what the cooling would be after a super eruption, which might last for several years, it would be enough to cause what we call a volcanic winter. And what that means is that the Earth would become so cool, so cold, that you'd probably lose a couple of growing seasons. And if that happened, there'd be mass starvation. And so that's a kind of civilization, not a mass extinction volcanic eruption, but it would certainly threaten civilization if you're going to lose, a couple of growing seasons. We don't have a backup of enough grain to get us through that kind of situation on a global basis. And so there would be a lot of trouble for the civilized world to get through that.
In Italy, in October 79 AD, Mount Vesuvius erupted, killing up to 3,500 people. They say maybe up to 16,000. They're not sure. Did those poor people have any notice at all, Michael?
No. That eruption, there were really no precursors that suggested that there was going to be an eruption. And so the eruption started in the morning, and it just went from there. And so there was really no real warning for the people in that area to try to get away. They were trying to get away during the eruption, but then, as you said, there was a lot loss of life, and those cities of Pompeii and Herculaneum were destroyed by the pyroclastic flows from that big eruption.
What causes a volcano to erupt? What builds up?
Well, there's these magmas that are inside the Earth are charged with gas. There's a lot of gas, CO2, and water vapor dissolved in these magmas, and as they come to the surface, that gas can be released, and it can be released explosively if the magma comes to the surface fast enough, and so that will cause an explosion. And so the magma doesn't come out as a lava flow; it comes out as particles, as pieces of pumice and fine ash and stuff. That's what's produced by an explosive volcanic eruption. And as I say, they're very hard to predict, and sometimes there's some precursory activity that allows you to say, well, there might be a big eruption coming, so maybe we better get people out of there. But very often there's not much precursory activity that tells you very much until the actual eruption.
What would you say, Michael, might be the biggest dangers to us on this planet now?
The biggest dangers? Well, I mean, of course, an asteroid impact would be the ultimate danger, but they don't happen that often. In the last really big one, it was 66 million years ago. That was the one that wiped out the dinosaurs. There've been some smaller ones since then, but so it's a rare event, which has a very big effect. And the same thing is true with supervolcanoes. They don't happen. They happen maybe once every 50,000 years. So they're relatively rare events. I'd say one of the biggest problems we have today in terms of sort of an existential problem for us is climate change. People have kind of ignored it or tried to ignore it for a number of years, but just look at what's happening this year. You can't ignore it anymore. You can't ignore the fires. You can't ignore the droughts. You can't ignore the super high temperatures. You can't ignore the very warm ocean temperatures that are going to wipe out the coral reefs. I mean, as you said earlier, it seems to be happening so fast, and I think it's because we hit a tipping point. Things were changing slowly, and then we hit a point where things started to change really fast.
In theory, if it's man-caused, it should get worse and worse and worse from here on in, right?
Well, as long as we're continuing to put...
If we keep doing what we're doing.
Yes. If we stop tomorrow burning fossil fuels, eventually it would start to get cooler. It wouldn't happen right away. But as long as we continue to put greenhouse gases, then I can't see us really cutting that down on a short-term basis. It's just going to get warmer.
Now, what's your definition of a greenhouse gas?
Well, it's a gas. There are a few gases which are greenhouse gases. CO2, for example, carbon dioxide. Methane is a greenhouse gas. And what they do is they allow sunlight to come through the atmosphere and warm up the ground, and then the ground warms up and then warms up the atmosphere. And the heat that's coming out to warm up the atmosphere is trapped by the greenhouse gases.
I had heard that we had high carbon dioxide levels lots of years ago, many years ago. Is that true?
Oh, yeah, sure. 100 million years ago, CO2 was very, very high, and the planet was warm. But those changes took place over millions of years, slowly, gradually. The problem with what's happening now is it's happening, over decades, and ecosystems, life on Earth can't adapt to changes that are happening that fast.
What's happening with the sea life right now?
I'm sorry.
Sea life, fish.
Well, if the temperatures in the ocean off of Florida are 100 degrees, that's reaching the limit of where lots of sea life can survive.
That's like cooking the fish in the ocean. My God.
Reefs are dying, and once they die and the temperatures remain 100 degrees in the water, they're not coming back. And so that's a big, potential, very, very major problem.
What's a normal temperature for the ocean?
In the summers?
Yeah.
Maybe 80 degrees, something like that.
So it's 20 degrees hotter right now. That's amazing.
Oh, yeah. Yeah. Now, maybe in a few years, it'll be even more hotter than that.
If we have cycles of winters, we could have a bad winter, though, right? Like you said.
Yeah, there's no guarantee that the winters are going to be any milder. It's the summer season that's the critical one.
And we've got another month of that, at least, don't we?
I'm sorry?
We have at least another month of that.
Yes. July was the hottest July on record, and I don't see why August wouldn't end up being the hottest August on record as well. I can make that prediction, I think, pretty safely.
Well, if this is caused by mankind, we're not going to change what we do any day quicker. So what happens?
Right. What happens?
Yeah.
Well, it'll just continue to get warmer. The more of these gases we put into the atmosphere, the warmer it'll get. So in San Antonio, it's 110 degrees, and in years maybe it's be 120 degrees, 130 degrees.
In theory, Michael, should it get worse next summer if things just stay the same?
I would say probably, since we're still putting more of the greenhouse gases into the atmosphere, we might expect it to be even warmer next summer.
Now, what happens if it's dramatically less? Then what do you say?
Well, there's always variability from year to year. But as I said, if you go back the last 20, 30 years, every year has been hotter than the year before. So there's a trend of warmer and warmer temperatures. And so this last couple of years, we've apparently hit a spot where we're seeing these very elevated temperatures. And as I say, this may just be a tipping point that we've reached. It's gotten warm enough so that there's so much extra heat in the atmosphere that we're seeing these very, very high temperatures across the whole world, essentially.
That's what really baffles me, Michael. This is not just a United States or a North American problem. This is worldwide right now. I mean, Greece is on fire. Everything's going crazy.
Well, the CO2 we put in the atmosphere is mixed into the atmosphere, goes everywhere. So we're putting CO2 in. China is, every country that's burning fossil fuels is adding to the CO2 of the atmosphere. That carbon dioxide is mixed around throughout the atmosphere. And so, you should see a fairly uniform warming.
I did not hear any meteorologists last year predicting this kind of weather this summer. Did you?
I don't think they predicted these kinds of temperatures, but I have a feeling they'll be predicting them for next year.
It'll be much easier to predict, that's for sure, sadly. Back to the asteroids for a moment. When you look at the moon, it's shattered with all kinds of asteroid holes and craters and things like that.
Yes.
If you dried out the planet Earth, the oceans and the vegetation, would we look the same?
No, because we've been hit by the same number of things. So there would be the same number of craters on the Earth, except that on the Earth there's erosion and there's volcanism and there are all kinds of things that would tend to erase the craters. And so there are about 200 known verified impact craters on the Earth, and we find a couple more every year. They're hard to find because they get buried, they get erased. But if there was no erosion on the Earth, if there was no geological activity, it would look like the moon.
That activity on the moon that shows all those craters, When do you think that might have occurred?
Well, most of it was early on in the history of the solar system, when the planets were forming out of those pieces.
4.5 billion years ago.
Yeah, maybe 4 billion years ago was this what's called the intense bombardment of the planets, when the moon and the Earth and the other planets would have been hit by a large number of, much more than we see hitting the planets now. And so a lot of the craters on the moon are old craters, very old craters.
Michael, we're going to take a break at the top of the hour here and come back and take calls with you. Michael Rampino, our guest, his website is linked up at coasttocoastam.com. We're talking about his work on cataclysms next.